I hope all of you are having a great Google Cloud Next 2023. Thank you so much for taking the time from your busy day and spending it with us. Over the next 45 minutes, we're going to be talking about Postgres. I'm going to kick it off by saying that I love Postgres. And the fact that all of you are here today means I think all of you love Postgres as well. Is that right? Make some noise if you love Postgres. All right, awesome. I needed that. So Postgres is one of the most popular open source relational databases in the world. And for good reason. Postgres has been in active development now for over 35 years. And it all started at the University of California in Berkeley, not far away from here, right? And because of 35 years of active development, what we have is an open source database that is robust, an open source database that scales really well, an open source database that is extensible, which means you can easily customize it for the use case that you have in mind. And last but not least, an open source database that is highly conformant with the ANSI SQL standards. Hundreds and hundreds of people around the world have contributed to make Postgres what it is today. And all around the world, just like how we've come together here today to talk about Postgres, there are hundreds of events and user groups where people who like Postgres come together, brainstorm, and learn from each other. So I want to take a moment to thank the Postgres community for making this open source database available for us. So this is the agenda for the next 45 minutes. We're going to do introductions. I'll introduce the speakers for today. We will then do an introduction of Cloud SQL and Cloud SQL for Postgres. We will then talk about some of the innovations we recently made in Cloud SQL, specifically around availability and performance, two vectors that are very important if you want to run mission-critical workloads on Postgres. We'll deep dive into them, and we'll talk to you about how we made these innovations possible. And like I said earlier, Postgres is highly extensible, which means that you can modify it quickly to meet the use cases that are important for you. One such use case that is which is of high interest right now is Gen AI. So we'll talk about AI and ML, and we'll deep dive into how you can use Postgres for building Gen AI applications. And after that, we'll bring two Cloud SQL for Postgres users on stage. They will talk to you about how they've deployed Cloud SQL for Postgres at scale, what lessons they've learned from that, and best practices that they'll share with you. We'll follow that with Q&A. So there's a mic over here. If you have any questions, please come up to the mic and ask those questions so that everybody can hear the question. Of course, Jana and I will be here after the session as well to answer any questions that you might have. So my name is Bala Narasimhan. I'm a group product manager for Cloud SQL. I'm joined on stage by Jana van Greunen. Jana is engineering director for Cloud SQL. We will be joined on stage with Richard Helms. Richard is a manager for database engineering at SalesLoft, and also Stacey Knapp. Stacey is an engineering manager for SRE at Penn Entertainment. So let's start off by a quick introduction to Cloud SQL and Cloud SQL for Postgres. So what is Cloud SQL? Cloud SQL is a managed service for relational databases. Cloud SQL is a tried and tested service. Upwards of 95% of all GCP's top 100 users use Cloud SQL today. Cloud SQL supports 3 relational database engines: Postgres, MySQL, and SQL Server. And we aspire to give you full compatibility with these 3 engines. And what I mean by that is, if you have an application that runs today and is leveraging one of those 3 engines, you should be able to move that application to Cloud SQL as is, and it'll just work. Cloud SQL is also fully managed and enterprise ready. What that basically means is with a few clicks or with an API call, you're able to provision a Cloud SQL instance. You no longer have to worry about provisioning infrastructure, patching software, setting up workflows for availability, data protection, disaster recovery, et cetera, because we take care of all of that for you. We take care of the mundane so that you can focus on what matters, which is building applications. We bring Google's best practices around security for you. And last but not least, we aspire to be developer-friendly. What we mean by that is, if there's a developer who wants to build a new application, we want them to be comfortable using Cloud SQL. To that end, we embrace infrastructure as code. We have full Terraform support. We have KCC support. We have a powerful API that you can use And every workflow that you can do through the console, you can do through the API as well. We also bring you developer-centric observability via query insights and system insights. It provides you a rich set of traces, logs, and metrics so that you can troubleshoot your instance quite easily. Cloud SQL for Postgres is Postgres as a managed service. It is open source Postgres. We provide you open source Postgres as a managed service. This means that you are able to leverage all the innovation that the community is building for you. And there's no concerns around using proprietary software because this is open source Postgres. Because it is a managed service, like I said earlier, we take care of the mundane for you. You don't have to provision infrastructure, you don't need to patch software, and you don't need to set up complicated workflows for things like availability and data protection. We take care of all of that for you. You can spin up an instance in a few minutes, and you can focus on building new applications. And Cloud SQL for Postgres is innovating rapidly. On the right-hand side of the slide here, you're seeing few of the innovations that we've had recently. The first is PG vector support, which allows you to build Gen AI applications. And as I said earlier, we'll be deep diving into that. Some other things is support for up to almost 200 flags and 50+ extensions. On the security front, there's support for IAM-based authentication and strong password policies for local username passwords. More recently, we launched PI3R support for unavailable instances. You're able to now do point-in-time recovery even when an instance is down, which reduces the RPO and RTO considerably. But we understand that a database is just one piece of the puzzle. As you're looking to build an application, you want an entire ecosystem around the database. You want solutions for migrations. You want solutions for BI and analytics. You want solutions for observability and security. And so we're really excited to announce Google Cloud Ready Cloud SQL partners today. So this is a set of tools that we have certified through a due diligence process to make sure that these tools work really well with Cloud SQL. Right? So you have the peace of mind that if you want to use one of those tools, they have gone through a rigorous technical evaluation process, and it works really well with Cloud SQL. All right, so now I'm going to spend some time talking about the innovations around availability and performance that we recently announced for Cloud SQL. Specifically, I'm going to talk about the Enterprise Plus edition for Postgres. As customers are bringing their applications to the cloud, they keep asking us for three things when they're talking about their most mission-critical applications. The first is higher performance, the second is higher availability, and the third is better data protection. And it was along these three vectors that we innovated when we announced the Enterprise Plus edition for Postgres. So two things to call out here for the Enterprise Plus. The first is improved performance and scale out of the box. And the other is business continuity, the improvements in business continuity. So let's deep dive into that. Let's talk about how we were able to deliver better performance and scale out of the box and what the better business continuity is. So as far as the Enterprise Plus edition goes, there's two things that we've done. Firstly, we have optimized hardware that we're using to provision these Cloud SQL instances. And secondly, because we run a very large fleet of Postgres, we understand how best to optimize the deployment of that Postgres software to best leverage the power of the hardware on which it's running. And it's a combination of those two things that allows the Enterprise Plus edition to have better performance out of the box. And we've seen up to a 2x improvement in write throughput for Enterprise Plus edition compared to the Enterprise edition. So what are the specific hardware optimizations we're talking about here, right? The first is that we're leveraging the N family of machines types, right? So we're using the N family machine type. So when you provision Enterprise Plus instance, you're getting an N family machine type. The second is a higher core to memory ratio. Compared to the Enterprise edition, where that ratio is 1:6.5, in Enterprise Plus, that ratio is 1:8, which means that for the same number of cores, you're getting more RAM, which in turn means that you're able to store more of the working set of your database in memory, which results in better performance. We also are supporting larger instance shapes with Enterprise Plus. We're supporting up to 128 cores and 864 gigs of RAM for a Postgres instance that's Enterprise Plus. This is in contrast to the Enterprise edition, where we support 96 cores and 624 gigs of RAM. So it's a combination of all of these hardware improvements that are allowing us to give you better performance. And as I mentioned earlier, because we have the learnings from running a very large fleet of Postgres instances, we also know how best to deploy that Postgres software in a way that will leverage these hardware improvements. And it's a combination of those two things that's resulting in the improved performance. And in our internal benchmarking, we have seen up to a 2x improvement in write throughput for Enterprise Plus compared to the Enterprise Edition. So what are the innovations we've made on the business continuity front? The first is that we announced a 4 nines SLA for Enterprise Plus. This is in contrast to the Enterprise Edition, which is a 3.5 nines SLA. In addition to that, Enterprise Plus has maintenance included in that SLA, meaning the 4 nines SLA is inclusive of maintenance downtime, whereas in the Enterprise Edition, the 3.5 nines SLA has a maintenance carve-out. The second thing is that we have reduced the amount of time, downtime associated with maintenance. We call it near zero downtime maintenance because that's exactly what it is. The downtime associated with maintenance for Enterprise Plus editions is close to zero. I have a demo that I can show you. We'll actually show you a Postgres instance that is undergoing maintenance, and you'll see the downtime associated with that. And last but not least, we're announcing 35 days of point-in-time recovery for Enterprise Plus instances. We have a number of customers who run in highly regulated environments where they need to be able to restore an instance for up to 35 days from a particular point in time. And so we are supporting 35 days of PITR. This is in contrast to Enterprise Edition, where we support 7 days of PITR. So just to summarize, the Enterprise Plus Edition has innovations on 3 fronts. There's improved performance out of the box. There's improved availability because of the increased SLA and because of the fact that maintenance is now less than 10 seconds downtime. And the third is data protection, where we're supporting 35 days of PITR for Enterprise Plus instances. And with that, I'm going to jump into the demo. So before I kick this demo off, and I hope the demo gods will support me here. What we're going to do, let me give you a summary of what I'm going to show you. I have a Postgres instance running 15.2, Postgres version 15.2. It's an Enterprise Plus instance. It's a production instance, which means that it's set up with HA enabled. What we're going to do then is we have a client that's going to connect to that Postgres instance, and this client is going to query for a timestamp from this Postgres database in a loop. So you'll see a timestamp being published continuously in a terminal on the right. And then we're going to kick off maintenance on the Enterprise Plus instance. Now, as some of you may know, we support what's called self-service maintenance for Cloud SQL. In that mode, we give you the patches, and you are able to do maintenance on your Postgres instance as and when you choose. So you have the flexibility in terms of taking maintenance when we do it for you. Or if you want further control on that, we support self-service maintenance, whereby you can maintain your instance as and when we choose. Right? And so what I'm going to do is I'm going to kick off self-service maintenance on this instance. There's a patch available. I'm going to install that patch. And when that maintenance is happening, you're going to see the client going through some disruption, right? Because the maintenance is happening, it's going to result in some downtime. You will see 2 seconds of hard downtime on that instance, and you'll see about 5 seconds or so, 5 or 6 seconds of brownout, meaning that pretty much most connections are going through, but there's a little bit of disruption, right? Overall, the downtime is going to be less than 10 seconds, with a hard downtime of just 2 seconds. All right, so let me kick this off. All right, let's see how this goes. All right, just to orient you here, on the left-hand side is the Cloud SQL console. That's the production Postgres instance. As you can see, where it's highlighted in green, it's a Postgres 15 instance. On the right-hand side is a client that is going to connect to this database. Enterprise Plus, highly available. And I'm going to show you the script now. As you can tell, this script, I'm going to pause this video for a second so you can take a look at what the script is doing. As you can see, it's running in a loop, and it's querying the database for a timestamp. All right? And so when I'm going to run this script now, All right, there you go. As you can see, it's publishing a timestamp in a loop. And now, take a pause this for a minute. You're seeing that there's a patch available, right? There's a patch available. And I'm going to do self-service maintenance, and I'm going to install this patch on this Postgres 15 instance. All right, maintenance has started. You're seeing the initial disruption there. That's the hard downtime that you're seeing. The application has come back up, right? You're seeing that disruption there. The application has come back up, and it's connecting to the database, and it's getting the timestamp back. You're seeing the intermittent connection loss there. Oops, what happened? OK. Sorry about that. I'm going to fast forward. That was the most interesting part. Yeah, so I'm going to pause this again. So you're seeing downtime started over here where the red arrow is, and downtime ended when the hard downtime ended in the first green arrow. So that's 2 seconds of hard downtime during maintenance, just 2. Okay, and then you're seeing the intermittent connections are coming through. Once in a while, there's a connection that drops, about 7 seconds of that. So this is in contrast, by the way, to the maintenance that you will have experienced in Enterprise edition of Postgres, where the average downtime is less than 30 seconds. So this is a 2x improvement in downtime in Enterprise Plus edition compared to Enterprise, right? So for your most business-critical applications, this is a very big deal and something you should take a look at. And definitely try Cloud SQL Enterprise Plus. All right, and with that, we're going to transition to AI and ML. And as I said earlier, Postgres is highly extensible. And a lot of our users want to build Gen AI applications on Cloud SQL for Postgres. And we heard that feedback. And we've introduced support for what's called PG Vector in Cloud SQL for Postgres. And we have a number of customers building these applications. Jana is going to talk about the technology itself and how you can go about building those applications using Cloud SQL for Postgres.
Cool. Awesome. Thanks, Bala. Yeah, I think in addition to all the really exciting things in Enterprise Plus, there's also some really new kind of application level exciting features regarding AI and ML in Postgres itself. So first, I'll ask a question. Who knows what a vector is? Maybe raise your hand. I know, maybe 4 or 5 months ago, none of us had really heard of it, but now it's something that's really taking the application world by storm. So what a vector really is, in sort of simple terms, is life is full of complex objects. We may speak many languages, there are images, there are videos. And a vector maps all of these into just an array of numbers. And you can think about that number, if you will, as being a spot in a multidimensional space. So you think, why is any of this important? Now you can take sentences, like a boy is running, and map that into a space. And the boy is walking. You can even take the Postgres elephant image and map that into that space as well. I think that may be quite far away from the boy walking or running. But the really, really cool thing about these vectors and using a model to create the vectors is that the things that are semantically closer, right? So a boy doing activities, they're actually closer in this vector space. And things that are further away, like maybe an adult running, will actually be further away. So let's say you're writing stories about children. You can actually do a search over all this data and find, for example, book recommendations about children's activities. And it's a very, very powerful tool if you want to add rich and smart experiences into your application. The other thing is that's all good, but why is this relevant to databases? Well, it turns out databases are excellent at storing data, numerical data for sure, in tables, building indices over those, and then finding what you need really fast. And so it's a perfect fit to enable this kind of new data type and new use case within the database itself. So the other thing, digging a little bit into how this might actually play out in an application, if we take a retail example, So let's say you had a data catalog in your database. Maybe you have some other details about your policies and how to shop in your store. You take all this data and essentially run it through an embeddings model that creates the vectors that we just talked about. And then these are stored back in the database. And that can be done offline. It can be refreshed periodically. So now a user will come around, and there's application running. And they ask maybe some questions like, what's the return policy? Or, hey, I'm searching for, let's say, an outfit to wear to a talk. Can you show me similar things or maybe appropriate clothing? These kinds of semantic questions are generally very hard to answer, but this vector grouping makes this all possible. And so basically the text question that they have will be converted by an LLM and basically then can be queried to find similar types of objects from the data, from the database. After that, it can be passed back into an LLM. So there's an integration here between databases and sort of the modeling, the pre-trained models in AI, and then passed back up to the user. So then the experience becomes a lot better. So as Bala mentioned, there is now a community extension called PG Vector that will enable all of these vector operations for you. So it supports a vector data type, it supports a number of indices so that you can easily retrieve similar results. And the other part is, why is this important? Why is this exciting? Again, having it all in your database is a really powerful thing. It means that any of your operational concerns are already taken care of. As Bala mentioned, all these mundane but very important things around managing your database, making sure it's available, applying security and other policies to it, those are already all taken care of in your Cloud SQL database. And so this is a very one-click easy method, installing the extension, to add a whole set of new capabilities to your application and have all of your application developers use a database in a stack that they already know and love. And so this is, again, we think having it in a database is really kind of a game changer. And I should say the PG Vector extension is available in Cloud SQL for Postgres, as well as AlloyDB for Postgres. So all of our Postgres interfaces will have this. And we already have customers using this. This is a quote from a retail customer called Find.com. And they said that by using this extension, they've really been able to vastly enrich their retail experience, give their users a lot more customizable content and answers. And they all did this with a database they know. So it was really easy for their application developers to just turn this on. And I will say this, I think if you didn't know what the vector or GenAI was before Google Next, please sign up for many different sessions that we have on it. So I will say enough about, we've given you a lot of information about all of the cool things that we've shipped and everything that's new within Cloud SQL for Postgres. We'd like to now actually bring some real customers, real users up onto the stage and hear, from, if you will, from the horse's mouth what their experience is. So please welcome Richard and Stacey. Cool. So to start off, I will have them both introduce themselves. And so Richard, can you please tell us a little bit about yourself, your role in the company?
Sure. My name is Richard Helms. I work for a company called SalesLoft. SalesLoft is a company that is basically a sales engagement platform. We also like to call ourselves the revenue workflow platform. We use something called, we have a product called Rhythm that leverages AI, and we look at people's sales data and their actions and integrations with their go-to-market integration products and things like that to help their salespeople engage better and make sales, their sales process better. So me, I work on the database engineering team, manage the database engineers. My role is to keep our data clean, healthy, performant, and that's really my role in the organization. So.
Great. Stacey, please.
Yeah, thanks, Richard. So I work at Penn Entertainment. We, of course, are an entertainment company at the core, as you probably guessed. We operate the Barstool Sportsbook, and Penn Entertainment also owns and operates 43 brick-and-mortar casinos and racetracks. About 2 years ago, Penn Entertainment acquired a company called The Score up in Canada, which is where I reside and my team works. And we develop and operate the Score Media and the Score Bet. And I mentioned Barstool Sportsbook. And some of you may have heard already that we've entered a partnership with ESPN to operate their sportsbook as well. My team is responsible for planning and deploying all of the infrastructure for cloud and on-prem, as well as the CI/CD processes, some security aspects, and just generally, keeping an eye on the performance and the health of the backend services.
Cool. Great. And so you're both Cloud SQL users, Cloud SQL for Postgres. If you can please talk a bit about how you use it today and maybe describe some details about the deployment. And we'll go maybe in the same order. So Richard, please.
Sure. We are a Postgres-only shop. As far as our development environments, we run Postgres in containers on the local developers' laptops. But from QA forward, we run everything in Cloud SQL. So our QA environments, we have probably 17, 18 QA environments plus a couple of SDET environments. And then we have multiple production regions. Each of our regions are broken out into separate Google projects. And each of those projects, we have what are called, we've got basically PostgreSQL instances for each microservice. We've got, at last count, I believe 48 microservices, each backed by a PostgreSQL instance running on Cloud SQL, various sizes depending on the use case. And the applications themselves all run in Kubernetes, either Elixir, Ruby, or Go is our application stack. So.
Cool. Very cool. Stacey?
Yeah, so our deployment is a bit unique in that we have data residency requirements. So because we're in the betting industry, we have to abide by a US federal law called the Wire Act. It basically means that you can't send betting data across state lines. So what this kind of means for us is, the way we architected our infrastructure is a hub and spoke model of microservices. So our core services will run in GCP in the cloud, all in Kubernetes, and then we also have all of our edge services that facilitate the persistence of bet data running at the edge. And those are all in Postgres and Kubernetes Anthos. The Postgres we all manage for on-prem directly. This kind of model equates to about 450 Postgres instances across all of our microservices, between about 6 non-prod and obviously production environments.
Awesome. So obviously when you run a Postgres instance in production, data protection is super important. Can you talk to us a little bit about how you've implemented data protection? Any lessons that you can share with the audience here today based on what you've learned doing that? Stacey, maybe I'll start with you.
Sure. So, obviously, because we're running a Cloud SQL, we don't have to worry too much about data protection. Google does most of that for us. But in terms of the backup and recovery scenarios, we obviously run with automated backups, 7 days of retention. We get the point-in-time recovery that covers the delta. And then also for operational protection, we run with delete protection on our instances for anybody's fat fingers. We also use automatic storage increases, that protects us from that kind of embarrassing moments when your disk fills up and you have an outage. But obviously that can cause like a runaway disk scenario, but that's obviously a reasonable trade-off to have. And then obviously, I think everybody probably agrees that running in multiple availability zones is also important, so we do that too.
And Richard?
Yeah, I would say we use very similar techniques. Probably the only thing that I think that I would also add there is that we do dual region backups. So I think that's probably important to point out. In addition to that, we absolutely are super, super careful about making sure that we have deletion protection on as well. Being a Terraform shop, the last thing we want to do is for someone to do a rogue Terraform destroy and our database goes poof. So, as far as lessons learned there, we certainly don't want something like that to happen.
Yes, for sure.
I think one other lesson I will share is that we kind of talked about maintenance, and Google is pretty rigorous on doing their updates and pushing them out. It's really important to be really paying attention to when those get scheduled and putting your maintenance exclusions in. So like the Enterprise Plus is really promising to see those 10-second maintenance windows.
So Richard, your comments on Terraform, I think, were a good segue to the next question, which is about Terraform. And we, as I was saying at the beginning of the presentation, developer friendliness is very important for Cloud SQL, and infrastructure as code is something that we embrace. We have support for Terraform. We have support for KCC. So maybe you can tell us, Richard. Maybe you can kick us off here. How do you use Terraform today? What are some best practices you can share?
Sure. We do use Terraform, as I mentioned before. We also use a wrapper called TerraGrunt. As far as best practices, I could probably share that best with a story. So we're a pretty good hypergrowth example organization. When I started with the organization about 4.5, 5 years ago, we were a pretty small SRE shop with about 3 SREs and a single database engineer, which was myself, and now we're about 9 SREs and 4 database engineers. And we started with a single Terraform GitHub repo and a single state file. And that was a bad idea. And we have since learned that it's a good idea to really think about your directory structure up front, really think about how many state files you need to have, really think about if you're going to do things like multiple regions and multiple deploys in different regions. All of these things matter. Your state files matter. Probably one of the bigger lessons we learned too was to separate your modules from your actual the development of your modules from your actual the rest of your Terraform resources themselves. So those are probably some of the best practices that I could probably share in that regard. So.
Yeah, I think one of the best practices I have is make sure that you hook Terraform up to some form of CI and constantly keep running the plan to make sure that it integrates well. It's pretty terrible when you have to open code that hasn't been touched in a couple months and it is just drifted entirely, and the plan just completely fails on you. Another kind of best practice I was thinking about was, when you're developing Terraform from kind of the start, to kind of really think about, what kind of abstractions you're building for your business. How do you group the resources that you want, and how do they, which ones frequently are changing? Maybe I'll give a bit of an example. So we tried to build a module that we could use to just spawn the entire stack. It's a template and it's backed by a few or a handful of smaller modules. And this, worked really great for us once we got it running. It turned our whole stack deployment from, weeks and days down to, hours. But once people came in and started, tinkering with it and trying to make changes, it kind of fell apart because the code complexity got really high. So, I guess to kind of pull it back a little bit, figure out where your groupings are and keep things smaller, and then figure out which layer you want to glue those back together at. Otherwise, you'll run into complexity issues.
Yeah, some great, I think, best practices there around hygiene and I think planning ahead with Terraform. And I think both of you run sizable fleets, multiple instances between different regions, data protection. So for Cloud SQL. So in terms of that, how have you approached observability throughout your deployment? And maybe Richard.
Sure. We are a Datadog and New Relic shop for a lot of our resources. But in addition to that, especially around alerting, because we alert on so much in our stack. But once we've crossed like CPU thresholds and things like that, we do start to fall back and start looking at the query insights tools inside of the Cloud SQL product. So once we've actually alerted on something that is pretty interesting to us, we do fall back on the query insights product. We use that to drill down and see what's pretty much on fire. We can identify broken queries pretty quickly and drill down and get to the root cause of the problem pretty easily. Typically, a bad index or a query plan that has changed over time for whatever reason, maybe some data skew or something like that. We can see it pretty quickly and get it addressed. The other thing about query insights that we really like is we'll occasionally use the tool to just rewind and go back in time and look for trends that just look out of the ordinary. So, and then we can be kind of proactive, and if we see things, or as I like to call them, bumps in the night that just don't look right in a particular environment, we can drill down and maybe get ahead of a problem before it becomes a raging fire in our environment. So. So we do certainly appreciate that observability in the Cloud SQL product.
Yeah, so our organization also has consolidated our observability and alerting into Datadog. So we use the natural GCP integration that gets us our high-level Cloud SQL metrics. We also have the logging, which uses the pub sub, which is kind of an unfortunate thing to have to deal with. We also use database monitoring directly from Datadog, which gives us the insights into Postgres itself, the explain plans and the query performance. We also actually still enable Cloud Insights on the GCP platform. Just as a secondary layer, if we do have some issue with the instance, we can contact Google and they'll give us a little bit of help if we need it. So yeah, that's pretty much our observability platform is fairly standard.
Yeah, great to see use of query insights as well as our integration and partner tools. That's super awesome. So another question, since we talked a bit about PG Vector, any chance that you see opportunities or applications for using PG Vector now that we have it? Stacey, I'll start with you.
Yeah, I think keeping with the theme of the conference with AI and ML, I think the obvious answer is yes. With our product, I think because we're in sports media, it would be really cool to just type into the app saying which player has this stat, and it'll give you all the references back. I think not having to shift our data to yet another data store is probably really awesome too. I don't think anybody likes having to shift data around out of Postgres if we all agree that we like Postgres. So yeah, I think it'll be really promising to see what's coming down the pipe for this stuff.
Yeah, I think in our regard, our data scientist team was beating down my door the day that PG Vector support was announced. They wanted an instance and they wanted it now. So the opportunity is definitely there. We've got product roadmaps that already have PG Vector in the works, in the plans. There's probably going to be something in our production stack probably in this quarter. So we're certainly already embracing the opportunities that are in front of us there. So
super cool.
So we talked a lot about maintenance, and I showed you the demo about the near zero downtime maintenance in Enterprise Plus. Cloud SQL gives you a number of controls. Stacey was referring to one of them in terms of either denying maintenance or delaying maintenance depending on your business requirements. It's an important topic, and both of you run a very large fleet. Maybe Stacey, you can kick us off by talking about how you think about maintenance for your Postgres instances and what are the different controls that you use today.
Well, maintenance windows with Postgres is not the most fun thing. I don't think, if you had to survey the room, like how many people would actually say they're running all the latest and greatest Postgres? I wonder if there's anybody still running less than 10, probably. So yeah, I don't think maintenance is a great experience right now, but the Enterprise Plus, yeah, I think it'll be really good. Yeah, but like you said, and I said earlier, we just use the maintenance exclusions. We really make sure we're really scheduling in those maintenance periods because our app can't go offline. And because we're really regulated, we have to give our release notes, a week in advance before we can actually push things out.
So in our case, we basically just set up notifications, and in the case where our scheduling doesn't align with our tolerated maintenance windows and maintenance schedules, we will go in and use the G-Cloud API to put in a maintenance exclusion and then reschedule the maintenance. But we will typically just allow them to go if they align with our prescribed maintenance windows. So for all of our instances, we do have, we set a particular maintenance window, but occasionally there are situations that, for whatever reason, we're sensitive to specific times of the month and times of the year that are bad, even though we have a weekly maintenance window. And so we'll adjust and whatnot. So we just set notifications. If the time's wrong, we'll override those notifications with a deny period, and then we'll just remove the deny period after the time's passed and let it go in the next window.
And we've talked a lot about Enterprise Plus, and I know, Stacey, you mentioned they are very excited about the near zero downtime maintenance feature. Anything else that you find interesting in Enterprise Plus itself? And same question for you, Richard.
I think just the general performance increase will be really nice to have. We see some bottlenecks already with going above 16 CPUs, so I think it'll be really cool to get a little bit more throughput out of those instances.
Awesome.
Yeah, I think a couple of things for us. Definitely the addition and the more memory, the addition of 8 gig per CPU. Yes, the 1 to 8 versus the 1 to 6.5. So I think that's a big deal for us. And in addition to that, the much smaller maintenance windows are going to be a huge win for us. 1 minute's not a big deal, but 1 second is certainly it's huge. It means that even in those less than desirable windows, maybe they're more desirable now.
Makes sense.
So I think those are probably the two things that I'm most excited about. So.
It looks like we're coming up on time here. Thank you so much for taking the time to attend this session today. Thank you for being part of the Postgres community. I appreciate the fact that all of you are as excited as us are about Postgres. There's a number of other Cloud SQL sessions in the next couple of days as well. Here's the list of sessions. Do attend and give us your feedback on them. Jana and I will stay behind to answer any questions that you might have based on what you heard. Thank you so much.